Welcome to another calculus TxePrep video, and in this video we're going to talk about derivatives. So derivatives are just a really fancy term for slope, and as you know, slope can be rewritten as this delta y divided by delta x, and that's basically just the change in y divided by the change in x. So let's just start with something we already know how to do, which is calculate the slope between 2 points. So let's say I have the curve x squared. So it's going to look something like this. So that's x squared right there. And I just want to know the slope between 0, 0, and let's say 3, 9. So we see here that the change in y is equal to 9. And we also see here that the change in x is equal to 3. So that means our slope between 0 and 3, 9 is simply just going to be 9 divided by 3, which is simply just 3. Okay, now let's say we want to do something a bit more different. What if we want to find the slope at a single point, the instantaneous slope? Just a point, there's no 2 points, so you can't get the average slope, just a point. Well, you may say then that the change in y is 0, and the change in x is also 0, so our slope would be 0 over 0. But the problem there is, we can't divide anything by 0. So what we use in this case is the limit. And more specifically, we make the change in x as close to 0 as possible. So it's going to be like something like 0.000, infinitely many zeros, followed by 1. So it's not exactly 0, but it's something we can divide by. So let me just draw a more close-up look. And I want to find the derivative at 416, or basically the slope at 416 of x squared. Well, this is going to be the change in x. And as you may know, we want the change of x to be as close to 0 as possible. And then our change in y will simply be equal to f of x plus the change in x, and f being the function, which is x squared. So we can rewrite the formula of slope applying to derivatives as the limit as the change of x approaches 0 of delta y, which is simply just f of x plus change of x, and then obviously you have to subtract f of x because it's a change, minus f of x divided by delta x, and delta x just remains the same. So now let's just try finding the slope at 416. So our function is going to be x squared, and our x over here is going to be 4. So let's just rewrite this, and this is going to be limit as delta x approaches of 0 of 4, which is x, plus delta x squared minus f of x, f of 4, and f of 4 is simply just 16, divided by delta x. And now I'm just going to multiply this out, so that's going to be equal to limit as delta x approaches 0 of 16 plus 8 delta x plus delta x squared minus 16. So these two terms cancel out right off the bat, and this leaves us with delta x. And now we can factor out the delta x from the top, leaving us with the limit as delta x approaches 0 of delta x times 8 plus delta x. And now we're going to divide that by delta x again, and that just leaves us with 8 plus delta x. And now we want to find the limit as delta x approaches 0, and when we use substitution for that, that just leaves us with 8. Meaning that the slope at 4,16 for x squared is simply just going to be 8. But what if we want to find the formula for an entire equation? What if I just want to find a formula for the derivative of x squared at any single point on the curve? Well, for that, instead of plugging in a specific x value, we can just leave it as x and then use algebra to solve it. So let's just repeat the process again. So it's going to be limit as delta x approaches 0 of f of x plus delta x minus f of x divided by delta x. And one more side note is that you may see delta x over here being represented as another variable, h. So x, now we're just going to plug in things. So this is going to be x plus delta x squared minus x squared divided by delta x. And obviously we have to take the limit. Edit. So we have to take the limit over here. And now when we expand this out, this is gonna leave us with the limit as delta x approaches 0 of x squared plus 2x delta x plus delta x squared minus x squared divided by delta x. And as you may see here, the x squareds cancel out, and we can factor out the delta x like we did before. So this is going to be the limit as delta x approaches 0 of, we factor out delta x, that leaves us with 2x plus delta x divided by delta x. And now when we cancel the terms out, that leaves us with the limit as delta x approaches 0 of 2x plus delta x. And using substitution for delta x, that just going to leave us with 2x. So that means the derivative of x squared is actually 2x, meaning that if we were to find another point, let's say at x equals 3, then the derivative would be 2 times 3, which is 6. So I hope you guys understood how we can use the limit definition of the derivatives to help us find the instantaneous rate of change at a certain point on a slope or graph.